Okay, so this video is just about finding our angles, okay? So you will know when to use a trig as your function when you're asked for the rate of change of an angle, okay? That's what you're gonna see. What is the rate of change of an angle? Okay, and the only way that we can have an angle is if you have some type of a trigonometry problem. So we're always going to set up a trig problem when we're asked to find the rate of change of an angle, or we're given the rate of change of an angle. Okay, it's similar to a Pythagorean theorem problem, but you're asked about angles. Okay, the Pythagorean theorem only talks about side lengths. Trigonometry relates all of our angles. Okay, so let's do a little review of our trig functions. There are 6 of them. Here are your basic 3. So for this angle here in the lower left, this is of course your hypotenuse, right? The side that makes up your angle with your hypotenuse is the adjacent side, and then the opposite side is across from your hypotenuse. Okay, so our sine is a ratio of opposite over hypotenuse. Okay, cosine is a ratio of the adjacent side and the hypotenuse. And the tangent is a ratio of the opposite side to the adjacent side. So depending on what 2 sides you know, well, one side will usually be constant and another side will be changing. Okay, which is good to understand, right? One side will be constant and one side will be changing. That's how we know that we're going to be doing a trig. But there are 3 other trigs, of course. They are the reciprocals. So cosecant is the hypotenuse over the opposite side, right? That's the reciprocal of sine. The secant is the reciprocal of cosine, so hypotenuse over adjacent side. And the tan's reciprocal is cotan, which is adjacent over opposite. Okay, and these are important to remember because you're going to be substituting in a trig ratio after we take the derivative with respect to time. So depending on what your derivative is, we're going to have to know one of these 6 ratios so that we can replace them to solve in your problem. Okay, so let's look at our steps. So here are your steps when we are doing these angle rate problems. Okay, number 1, decide what trig to use. Okay, what 2 sides do we know? One side will probably be constant and the other side will be changing. Identify your sides. Okay, oh, here we go. Decide what side is changing and what side remains constant. Boom, simple. And then this is where we're going to set up your trig ratio. So maybe we decide it's sine, maybe we decide it's cosine, maybe it's tangent. Right? You set up your trig ratio here, and then we do the calculus. We take the derivative with respect to time for each variable. Don't forget about d theta dt. We're always going to have a d theta dt whenever we take the derivative of our trig. Okay, so don't forget about that. It goes on the same side of your trig, as we will find out. Okay, and then here we're going to find the ratio fraction for our trig derivative after we take the derivative, and we're going to replace it, and then we're going to solve for everything else after that. Okay, so these are our steps that we're going to do, with number 3 and number 4 probably being the most important steps to remember when we're doing a trig related rate problem in calculus. Okay, let's see how this works with an example. Okay, Connor is standing 20 feet from a flagpole, watching a flag be raised at a rate of, so here's our rate, 1/2 of a foot per second. At what rate is Connor's angle of elevation changing when the flag is 20 feet up the pole? Okay, so first let's do a little drawing. Okay, we're going to put Connor here. I'm going to put him on the left side. There's C for Connor. Okay, so we have the ground. Of course, the ground is going to be horizontal. We're assuming that we're not standing on a hill or anything. It's flat ground. And here we have the flagpole, okay, with our lovely flag on it. Okay, so the flag and the ground make a 90-degree angle, right? That's one of our assumptions, that we're not on a hill or a slanted. So we can connect Connor with the top of the flagpole to create a right triangle, right? Because this is our angle of elevation. The angle of elevation is formed with Connor and the ground. Okay, and as the flagpole goes up, Connor looks up, right? Because his eyes are following the flagpole. So what's constant? Connor is 20 feet from the flagpole. So that's our ground distance, right? From the ground, from Connor to the flagpole is 20 feet. He's not getting any closer to the flag. He's not getting any farther away from the flag. He is standing still. So then what is changing? The height of the flagpole, right? This is changing. The flag is going up. So what variable do we want to represent height here of the flagpole? H is fine. So this is our H. So H is changing, right? We know that the flagpole is being raised at a rate of 1/2 of a foot per second. Right, so once we label our height, right, that variable, then we can go ahead and talk about what the rate of change of that variable is. Okay? And we want to know what is the angle of elevation changing when the flagpole is 20 feet. So let's start here. What sides of our angle do we know? 20 is the adjacent side, and H is the opposite side. Very good. So which trig relates the opposite and the adjacent side? The tangent does. So we're going to have a tangent ratio problem, and that's H, the opposite side, which is changing. So that gets a variable because the opposite side is changing, but the adjacent side is always going to be 20. Okay, so tan of theta equals H over 20. That's our equation that we're going to be taking the derivative of. Okay, so that's where we start. We have done step number 1 and number 2. And now let's go to step number 3. Take the derivative of this with respect to time. So what's the derivative of tan? Secant squared is a derivative of tangent times d theta dt, right? Theta is a variable. So we have to add in this d theta dt. If I see students make a mistake, it's because they forget to do the d theta dt after our trig derivative. The derivative of tan is secant squared, and then we take the derivative of theta with respect to time. Okay, now I'm going to change my h over 20 real quick to 1 over 20 times h. Okay, does that make sense? That h over 20 can be written as 1/20th times h. Because now, what is my constant? 1 over 20. So that's going to remain when I take the derivative. And what's the derivative of h? Just your dh dt, right? It's the constant 1 over 20 times dh dt. Wonderful. You've just done the calculus, right? That's taking the derivative with respect to time of all of our terms. Now, let's get to plugging in what we know. So let's come over here. Do we know what the secant is? No, we don't know what the value for secant is. We want to find d theta dt. We have a constant of 1 over 20, and our flag is being raised at a rate of 1/2 of a foot per second. So there's your dh dt, the rate at which the height of the flag is changing. So we have to come back and do some work in order to get our secant. Okay. This is where we know that he's 20 feet away, and the pole is also, the flag is 20 feet up the pole. So let's draw that instantaneous situation. Right, we know that Connor is 20 feet away, and the flag is 20 feet up the pole. So what is our hypotenuse going to be? Because remember, secant is a ratio of the hypotenuse over the adjacent. So we have to calculate the hypotenuse. Okay, so we can of course use the Pythagorean theorem, 100% correct, or what kind of a special triangle do we have here? A right triangle, but also an
with both legs.
Isosceles right triangle. So when an isosceles right triangle, right, both of these angles are 45 degrees, a 45, 45, 90. So if you remember from your geometry, which I don't think you do, the hypotenuse is the side length times the square root of 2. Okay. Now we could have found that doing the Pythagorean theorem also. 20 squared plus 20 squared equals like 800. And then if we simplify the square root of 800, we would get 20 roots of 2. And it's okay if you decimalize that, that is just fine. So the secant, the hypotenuse was 20 roots of 2 divided by our adjacent side, which is 20. So 20 divides 20, and my answer is just root 2. Okay, this is probably one of the hardest parts of this entire problem, is figuring out what your trig ratio is to substitute in. Okay, because it takes some remembering if it's not a straight up Pythagorean theorem problem. So we're going to put root 2 in here, but what do we do to our root 2? We have to square it, right? It's secant squared, so I have to square my secant ratio. So I'm going to square this before I do any math with it. Okay, excellent job. Now that we have all of our things in there, we can simplify. Root 2 squared is normal 2 d theta dt equals 1/20th times 1/2 is 1 over 40. Right, because 20 times 2 is 40. Now, my last step is to divide both sides by 2. And if I have a fraction, I multiply by 1/2. And 1 over 40 times 1/2 is 1 over 80. Okay, and what are my units for the angle? What are my units for angle in calculus? Always radians. Okay, so whenever we're doing an angle problem, this is radians per second. So our eyeballs are not moving very much at all. 1 over 80 is not a very large angle to begin with. So our angle of elevation is not going up very fast. So here's example 2. A 25-foot ladder is being pulled away from a house at a rate of 5 feet per minute. At what rate is the angle between the ladder and the ground changing when the ladder is 15 feet away from the wall? Okay, so let's draw this. Here's the ground. Let's draw the ground. Okay, and then here's the house. Okay, draw your house however you want. So here's some shingles on the house. No, just kidding. We're assuming once again that the house and the ground are perpendicular. Okay, that we're not talking about an angle or a slant. We're talking about flat ground. So then here is your ladder from the house to the ground. Okay. So what kind of a triangle do we have? A right triangle. And what's the ladder length? 25. So that's not going to change, right? 25 is a constant ladder length. It is not getting shorter or growing. It is staying at 25 foot. Okay, and what direction are we talking about? Where's our rate of change? Right, it's this direction. The ladder is being pulled away from the house. Okay, which means that this side of the ladder is going down when the right side is going out. Okay, so what do we know is changing? We know the house side or the ground side? We know the ground side. Okay, so that's our variable. That's what we know is changing, is the ground side. And it said, at what rate is the angle formed by the ladder and the ground? So that's going to be this angle right here. At what rate is that angle changing? So it's important to know which angle are we talking about, because that affects our trigonometry. So for that angle, 25 is the what side? 25 is the hypotenuse, and x is the what side? X is adjacent. So which trig relates the adjacent and the hypotenuse? That would be the cosine. So our ratio is cosine of theta equals x over 25. So taking the derivative of cosine is negative sine times our rate of change with respect to time. So d theta dt for our theta equals, once again, our constant is 1 over 25. Right? So we can write this as 1 over 25 times x. So 1 over 25 is your constant, and then we have your dx dt. Every variable gets a derivative with respect to time. Okay, do we know dx dt? Yes, we do. The ladder is being pulled away at a rate of 5 feet per minute. So that's our dx dt. The ladder is being pulled away at 5 feet per minute. Okay, we of course don't know d theta dt. That's what we want to find. So now we need to look at our triangle and get your sine fraction. Our sine fraction. Okay, so this is where we use the fact that the ladder is how far away from the wall. What does it say in the problem? The ladder is 15 feet away from the wall. This is where our 15 comes in. Our 15 helps us figure out what our ratio is for sine. Because sine is opposite side over hypotenuse. So we have to take a second, use our Pythagorean theorem, and figure out what our opposite side is. 15 squared plus y squared equals 25 squared. Okay? This happens in every single problem. We're going to have to figure out what our third missing side is so we can write down our trig ratio. So according to Pythagoras, that means I have a vertical side of 20. 15, 20, 25 is an iteration of our 3, 4, 5 triangle. 3 times 5, 4 times 5, 5 times 5. So the sine of our angle is 20, right? That was the opposite side that we just calculated, divided by 25, your hypotenuse, which can reduce to, if we divide these both by 5, reduce to 4/5. So that's what I'm going to plug into my formula instead of sine. The sine fraction is 4 over 5. So now that we have all of our information, let's go ahead and do some simplifying. 5 times 1 over 25 reduces to 1/5, right? And then if I want to get rid of 4/5, I'm going to multiply by its reciprocal. What is the reciprocal of 4/5? 5/4. So I'm taking my negative 4/5, I am multiplying by its reciprocal, or dividing by 4/5, in order to move my negative 4/5 from the left to the right. So I am multiplying by 5/4. That's how I get rid of 4/5, right? The 4's cancel, the 5's cancel. So when I simplify, 1/5 times negative 1/5, my answer is negative 1/4, and my units are radians per minute. I always have a radian as my angle unit. and then my time was minutes. Okay, so anytime, every time you're asked to find the rate of change of an angle, you're going to set up a trig problem and take the derivative of your trig ratio. Okay, very good job.